Hello, in today's video we'll be taking a look at this setup to try and find the normal stresses in rods 1 and 2. Now these rods are both cylindrical and they are fixed together at point B as shown. So starting with what we know the diameters of both of them. We know diameter 1 is 5 millimeters and diameter 2 is 3 millimeters. So right from this we can find the cross-sectional areas of these rods using simple circular area formula. However, we divide the diameter by 2. So we get that the area of 1 is 19.6 square millimeters and the area of rod 2 is going to be 7.1 square millimeters. Now, that's just one part. We know that for normal stress, it's equal to force per area. We know the area now for both rods, but we need to know the internal forces acting to calculate the stress. So let's start with rod 2. We'll draw a quick free body diagram and a cut as shown like this. We know we have a load of 2p acting like this at the bottom, and then we have our internal normal force. We'll call this N2. Now, if we do sum of the forces in the y direction like this, we get that N minus 2p, N2, is equal to 0. So that means N2 has to be 2p. Or, since we know that p is 10 newtons, our normal force in rod 2 is going to be 20 newtons. So awesome, we know our force and area for rod 2, so we can calculate the stress, but let's just keep going and find the force in rod 1 so we can calculate them all at the same time. So now I'll draw another free body diagram, this one for rod 2, or for rod 1, like that. And we know in this free body diagram we have the same 2p load at the very bottom, but now we also have this other load right here, right? Also pointing down, but its magnitude is just p. And then here is going to be our internal normal force for rod 1. So same thing like we did before, we're going to do sum of the forces in the y direction, it's going to be 0. So we know N1, I'll label this P. N1 minus P minus 2P is equal to 0. So we get that our internal normal force for rod 1 is going to be 3P or 30 newtons. So now we know both the area and the internal forces acting for each rod. So now we can calculate the stresses acting in them. So let's start with rod 1. We'll say our normal stress in rod 1 is going to be our normal force 1 divided by area 1. And using what we know that's really just going to be 30 divided by our area 1, which is 19.6, which gives us a stress of 1.53 megapascals. Now let's do the same thing for rod 2. We know sigma 2 is going to be N2 divided by area 2. And looking at these values, we know that our N2 is 20 newtons, and that is over an area of 7.1 square millimeters, which gives us a normal stress of 2.82 megapascals. So these right here are our final answers for this problem. Yes, so I hope this tutorial was helpful, and yeah, thank you for watching.